Okay, welcome back, class. Today we're going to look at the standard APR 101. In this standard, we will be looking at multiplication of polynomials. And so let us start. Let us consider the monomial by a binomial, which is 2 times the expression 4x minus 7. To get that, ladies and gentlemen, we're going to apply the distributive property. Some of you may be very familiar with it by the name of FOIL. And we end up having the 2 multiply the first term, which is 4x, and also the 2 multiply the second term, which is negative 7x. And we end up with 8x minus 14. You should not have any problem with this. Follow the step. This is called the distributive property. Let us look at another one where we have negative 3 times the expression binomial negative 7x minus 1. So we follow the same procedure. Then negative 3 multiply negative 7x plus, ladies and gentlemen, negative 3 times the negative 1. And at this point, we get 21x. It is positive because the multiplication of signs, 2 negative makes a positive, and plus 3, negative 3 and times negative 1 gives you positive 3. And now, I would like you to try this by yourself. It is rather quick. Go ahead. And your answer should have been negative 7 times x plus negative 7 times 3, and you end up with negative 7x minus 21. Alright, try another. The expression 6 times 5x minus 9, you should end up with 6 times 5x plus 6 times negative 9. And you have 30x minus 54. Now, let us look at properties of exponent. In doing so, we're going to focus on multiplication. All right? So, let us see what we have here. If we have 2 terms that are being multiplied by each other, where they have the exact same letter, you do not worry about their exponent because we're not adding. We do not need them to be like terms. If the bases are the same, which means the letter only are the same, and we are multiplying it, ladies and gentlemen, what we have to do is multiply the coefficients, which is the number in front of the letter, and then we add the numbers on top of the letter. That is referred to as the degree. All right, as you can see here, there's an invisible 1 in front of each x. Since there was no exponent display, there is an exponent 1 on each. And this becomes, ladies and gentlemen, 1 times 1 is 1. And we keep the letter, which was the base, and we add the exponent. It becomes x squared. Now, let us look at another one. See, here we have negative 7x cubed times 4x. We're going to follow the same protocol, which means we're going to multiply the coefficients that are in front of the letters, and we're going to add the exponent. In this case, the coefficients are negative 7 times 4, all right? And the degrees or the exponents, we have 3 and 1. Notice where the x is displayed with no exponent, there's a 1 there. So we end up having negative 28x to the 4th power. All right? And now, I would like you to try these 3 expressions, simplify them, and see what you get. Well, your answer should have been the following. for 6m to the 4th times negative 5m to the 7th. It is 6 times negative 5, and m, where the exponent is 4 plus 7, and you should end up with negative 30m to the 11th. That's what you should have. And let's look at the next one. Similarly, when we have negative 3 going to multiply 9, and we keep the letter P as it ought to be, and 7 plus a negative 2. It doesn't matter what the exponent looks like right now. I want you to think of it. If we are multiplying the terms, we add the exponent as long the letters are the same. So at this point, we get negative 3 times 9, which is negative 27, and 7 plus a negative 2, ladies and gentlemen, becomes 5. And now, last but not least, negative 2n cubed times negative 8n to the 4th becomes negative 2 times negative 8, and we keep the letter n since the bases of the letters are the same, and we add the exponent where we have 3 plus 4. And ladies and gentlemen, you end up with 16, because two negatives make a positive when we multiply, n to the 7th power. Now, I would like you to complete the following and turn them in for a grade. Okay, thank you.